Hey everyone, today we're going to break down something called the inclusion-exclusion principle. Now that sounds super formal, but really, it's just a powerful way to count things accurately when they start to overlap. It's all about making sure we never count the same thing twice. So let's see how it works. All right, let's just jump right in with a little puzzle. Let's say you've got two different tests for your software. Test A, it catches 60% of the bugs. Test B also catches 60%. So naturally, you run both. Does that mean you have 120% bug coverage? I mean, that can't be right. It's impossible. So what is actually going on? The reason that math doesn't work is because of this really common trap we all fall into, double counting. See, it's almost certain that some of the bugs found by test A are the exact same bugs found by test B. When you just add 60 and 60, you're counting that overlapping group of bugs twice, which gives you that crazy inflated number. Now, there's a formal way we talk about this, and it uses the concept of a union. When you see this U-shaped symbol, it means the union of A and B. All that means is we're interested in the chance that A happens, or B happens, or, and this is the key part, that both of them happen together. The big keyword to remember here is or. So how do we get around this double counting problem, at least when there are just two things overlapping? Well, luckily for us, there's a really clean and simple solution. It's called the general addition rule, and it's our first step to getting our numbers right. And here it is. It's actually pretty intuitive. To find the probability of A or B happening, that's our union, you first add the probability of A and the probability of B. But then, to fix the double count, you have to subtract the probability of A and B happening at the same time. We call that slice of overlap the intersection. And subtracting it is what makes the whole thing work. Let's make this super concrete with an example that has nothing to do with bugs. Imagine we have a class. 40 of the students know Python. 30 of them know Java. If you just add them up, you get 70. But wait, turns out 10 of those students know both languages. We've counted them twice. So the fix is simple, right? It's 40 plus 30, and then we take away that overlap of 10, which gives us the real total, 60 students. Okay, so that feels pretty straightforward. Add the groups, subtract the overlap, we got this. But what happens when things get just a little bit more complicated? What happens when a third event gets thrown into the mix? Let's head back to our programming class. What if, besides Python and Java, we find out some students also know C++? All of a sudden, our simple little formula of add 2, subtract 1 just isn't going to cut it anymore. We've just stumbled into a whole new kind of counting trap. So here's the brand new problem. Our first instinct might be to just subtract all the overlaps, right? We subtract the Python Java folks, the Python C++ folks, and the Java C++ folks. But if we do that, we create a new issue. Think about the students in the very center, the ones who know all three languages. By subtracting all three pairs, we've actually removed them from our count too many times. We've created a hole in the middle. We went from overcounting to over-subtracting. This is where the full inclusion-exclusion principle finally comes to the rescue. And honestly, the best way to think about it isn't as a big, scary formula. Think of it like a simple rhythm. You include, then you exclude, and then you include again. It's just a little three-step dance to get the count exactly right. Step 1 of our dance, include. We start by just adding everything up. Add the Python group, the Java group, and the C++ group. Yeah, we know this number is too high because of all the overlaps, but that's okay. It's our starting point. Step 2, exclude. Now we start to correct our mistake. We subtract each of the pairs. We take out the Python and Java overlap, the Python and C++ overlap, and the Java and C++ overlap. This gets us a lot closer to the real number. But this is the step that creates that over-subtraction problem we just talked about. And here's the final brilliant move. Step 3, re-include. We have to add back that small group in the very center, the ones who are in all three categories, because we took them away too many times in the last step. This one final addition perfectly fixes our calculation. And that is the full formula. I know it looks a little intimidating written out like this, but it's just formalizing that simple rhythm we talked about. Add the singles, subtract the pairs, and add back the center. It's just a logical sequence of corrections to make sure every single person or bug or server is counted exactly one time. So just to quickly lock in the terms we've been using, remember, union with that U symbol basically means or. It's the total area of all the circles combined. Intersection, the upside down U, means and. It's only that specific overlapping part where both things are happening at the same time. So you might be thinking, okay, that's a neat math trick, but why does it matter? Well, this isn't just an abstract puzzle. This principle is absolutely fundamental in engineering, in risk analysis, and computer science. It's used all the time to build things that are reliable and efficient. For instance, when an engineer calculates the reliability of a system with 3 backup servers, what are they really asking? They're asking, what's the probability that server A or server B or server C is working? That's our inclusion-exclusion problem right there. The exact same logic helps optimize complex database queries, or just like in our first example, helps you figure out what your true software test coverage really is. If you only take one thing away from all this, let it be this piece of advice. The biggest and most common mistake is simply forgetting about the overlap. So from now on, anytime you're about to add 2 probabilities or 2 groups together, just pause for a second and ask yourself, can these 2 things happen at the same time? If the answer is yes, then you know you have to find that intersection and subtract it. And that kind of leaves us with one last thought. This whole idea of correcting for overlaps goes way beyond math and engineering. Think about it. When you're planning your week, you have to account for tasks that might overlap. When you're making a budget, you have to make sure you're not counting the same expense under 2 different categories. So where else in your life does this simple mistake of double counting lead you astray?